Warm up for Lesson 3-1, Solving Systems of Equations. Pause to do the problems. And here are the answers. 3-1, Solving Systems of Equations. Objective, solve systems of linear equations graphically and algebraically. Let's take a look at two linear equations, and go ahead and graph them. Notice that to graph them, it's a good idea to get them into the slope-intercept form. And so we solve for y, and on this one we solve for y as well. This one has a y-intercept of 0, so we here start at 0, and then go up 1 over 2, up 1 over 2. Over here we have a y-intercept of 6, and we go down 1 over 1, down 1 over. We can see where they intersect is 4, 2. This means 4, 2 is a solution for both equations. Let's go ahead and solve this system graphically. All right, what I'm going to do is, first I went ahead and solved for y for this one. So y is by itself. I can see my y-intercept is at 4, and I can see my slope is -5. So I'm going to go down 5 units, 1, 2, 3, 4, 5, and then over 1. As soon as I get my 2 points, I can go ahead and graph my line. All right, and now I'm going to take a look at solving for y. What I did is I took the y to the other side and put 2 to the other side. So I can see that my slope is, my y-intercept is -2. So I'm going to use -2, and my slope is up 1 over 1, up 1 over 1. Let me go ahead and graph my line. I can already see my answer though. And the answer is 1, -1. And you can double check your work by substituting in here to see if you get the correct answer, and then substituting in here. All right, your turn. Please pause and do the problem. And here's the answer. All right, there are 3 ways two lines can position themselves in the coordinate axis. One, they could have intersecting lines where there is a solution, and this solution is a solution for both lines. You could have it where it's exactly the same line, therefore they have an infinite number of solutions. And you could have 2 lines that are parallel that will never intersect, and then that is no solution. This is represented by the word inconsistent, consistent and dependent, consistent and independent. Pause the screencast and decide what type each of the graphs represents. And here are the answers. Go ahead and stop the screencast to see if you can answer this question. And here's the answer. This one is the false statement because it can't be consistent because they have the same slope. Therefore, they must be parallel. All right, let's take a look at another method to solve other than graphing, and that's called the substitution method, where we solve one equation for one of the variables, substitute it into the second, and then solve. Let's take a look at these examples. In this particular one, I circled the variable that's by itself, and I went ahead and I took the 2x to the other side. I'm going to go ahead and continue. Now I'm going to put this in the one at the top. So this is going to be 5x minus 3. I'm going to substitute equals 23. And what I'm going to substitute is what y is, -2x plus 7. All right, now I'm going to do 5x plus 6x minus 21 equals 23. This is 11x equals, and when I add 21 to both sides, that's going to be 44. So x is equal to 4. Once I get x is equal to 4, I'm going to go back to this equation. Y is equal to -2, and now I have a value for x, which I'm going to put in as 4, and therefore y is equal to -1. So the solution is going to be 4, -1. And again, you can check your work to make sure it fits on both of this. Here I kind of got a head start. Solve for x, and then what I'm going to do is bring x and substitute it into the lower one. So this is going to be 35y plus 55 plus 4y is equal to negative 23. I now have 39y is equal to negative 78, so y is equal to negative 2. I'm going to go back up to here, x equals 7. I'm going to substitute my y plus 11, and the y I'm substituting is negative 2. Therefore, x is equal to negative 3, negative 14 plus 11. So that's the solution will be negative 3, comma, negative 2. Over here, I went ahead and isolated y, took y and substituted into the lower one, did all my algebra until I got to negative 5, and then took negative 5 and substituted into this relationship to get y. Okay, pause and try to do these two problems. And here's the solution. Okay, the third method is called the elimination method. That's where you multiply one or both equations by a number that results in two equations that contain opposite terms. You then add the equations, eliminating one variable, then solve. In this situation, it looks like y has opposite terms, a positive 3y and a negative 3y. So it's ready to go ahead and add. So this will be 7x, this will add to 0, and this will be negative 21. Okay, now I can solve x is equal to negative 3, and then to get my y, just pick either equation. I'm going to pick the first one. I'm going to put a negative 3 in for x. 3y is equal to negative 12. So now I have a 3y equals negative 6, because that's a negative 6 here, and adds 6 to both sides. Y is equal to negative 2. So the solution will be negative 3, comma, negative 2. And again, you can check your answer, take a minute to substitute to see if that is correct. All right, let's go ahead and do it again. In this case, I don't have opposite variables, so adding would not be a good idea at this point. So what I think I'm going to do is I'm going to multiply this by negative 1 and multiply this side by negative 1. Now I'll have 5x plus 3y equals negative 19. I'll have a negative x minus 3y equals positive 25. Now I have opposite variables, so I can say negative 3x equals, and then this is going to be a positive 6. So x is equal to negative 2. Go ahead to figure out your y. You're going to substitute negative 2 in for x in either equation. And I'm going to have negative 10 plus 3y equals negative 19. 3y is equal to negative 9. Y is equal to negative 3. So the solution is negative 2, negative 3. This is the point where the two lines intersect. Pause, and here's the answer. All right, let's take a look at solving a system again. And in this situation, I don't have opposite variables, so what I'm going to do is multiply this side, trying to get my red. So I'm going to multiply this side by, if I want to eliminate the x's, I'll multiply it by negative 3 and multiply this side by negative 3. Okay, so now what I have is a negative 15x minus 9y equals negative 156. And then I have 15x plus 9y is equal to 54. Okay, so I have opposite variables, 0 is equal to, and this will be negative 102, which does not make sense. This doesn't make sense. So if my result doesn't make sense, it means I must have had parallel lines. And parallel lines are what we call no solution. Okay, let's take a look at solving this system of equations. I noticed that I don't have opposite variables, so I decided to multiply the top by -3 and -3, so I got this result. And now I have a new way to write the top equation, which is this. I've multiplied by a -3. I write this exactly the same way, and let's see what happens when I add opposite 0, and then this is equal to 0. Now that is a true statement. 0 is equal to 0. When that happens, that means you have an infinite number of solutions. It's making sense, but it's not giving us one answer. So I went ahead and I solved for y for each one of them, and I noticed that the slope was the same and the y-intercept was the same. So that made me verify that they were the same equation. Pause, and here's the answer. Using the substitution method, let's take a look at this word problem. A rocking chair sells for $265. An Adirondack chair with footstool sells for $320. So, and the business earned $13,930 for 48 chairs. We want to know how much of each chair there is. So we'll let X be the number of rocking, Y the Adirondack, and I know that when you add the numbers, that makes 48, and when you add the amount of money each is worth, that adds up to this. So I'm going to go on to the next screen. I want to take this top one and I multiply it by -265 so it can match and have opposite variables. And I'm going to multiply that. So this now becomes this. And when I add, I'm going to get 55y equals 1,210, which leads me to get 22. Once I get 22 of those chairs, I can figure out how many rocking chairs there are, and there'll be 26 of those. Pause, and here's the answer. Let's take a look at one more. Please pause. And here's the answer. Notice that the slopes were the same, the y-intercepts were different, so that means that they were parallel.